Hello everybody. In this video we're going to show you how to determine if your HydroFLOW unit is installed in an electrical loop. The hydropath signal used by all HydroFLOW models has a very distinctive and easily recognized shape that can be measured with an oscilloscope. It is important to ensure the unit is installed correctly so that this signal can propagate throughout the plumbing system. If the unit is installed in what we call an electrical loop, this signal will not be able to propagate correctly and performance will be reduced. An electrical loop is caused when the HydroFLOW unit is installed in a location where there is an easy electrical path from one side of the unit to the other, a short circuit of sorts. In this situation, the electrical current does not have to travel through the entire piping system to ground, but rather has an easy path back to the other side of the unit, causing the signal to become trapped, which damages the equipment along with greatly reducing its performance. In many cases, electrical loops can be spotted before installation, for example, metal pipe hangers attached to a steel support beam on either side of the HydroFLOW unit. These pipe hangers provide an easy path for the current to flow back to the unit, trapping it in a loop. By electrically insulating the pipe hangers with a rubber gasket, we can eliminate this type of electrical loop. In some cases, an electrical loop isn't as easy to identify with the naked eye. In these cases, we'll use our oscilloscope to check the output from the installed HydroFLOW unit while off pipe and on pipe to determine if it is being affected by an electrical loop. First, we'll make sure our scope is set up correctly to display the hydropath signal. Note, for industrial units, we'll use the ×10 probe setting. For detailed scope settings, check out this document. Using this I100 unit, we'll first check the signal output with the unit off pipe by installing it with the ferrites arranged above the transducer rather than around the pipe. The signal output of a custom-sized unit should be performed with the unit on a bench as demonstrated in this picture. We'll check the signal at 3 different time settings: 20 microseconds, 2 milliseconds, and 2 microseconds. During this step, it is helpful to freeze the screen and take a picture of each reading to compare with the on-pipe readings that we'll get in the next steps. Ensure the unit is showing a proper hydropath signal at 20 microseconds. Depending on the unit size, the peak-to-peak voltage could fluctuate between 80 to 110 volts at 2 milliseconds. The frequency should be between 120 to 170 kHz at 2 microseconds. Now we'll install the ferrites around the pipe on this test stand, which has been intentionally set up in an electrical loop. Since all plumbing systems are grounded, we connected the stand to earth ground. Next, we'll repeat the same scope measurements and compare them to the off-pipe measurements. If the signal resembles the one on the right, or if the peak-to-peak voltage drops by 30% or more, or if the frequency is over 200 kHz, the unit is in an electrical loop. If the unit is in a loop, it will need to be repositioned, or pipe hangers will need to be insulated, or a rubber expansion joint will need to be added. Thanks for watching.